Bible talks about the water above the atmosphere. It mentions it in Psalm 148 as waters that be above the atmosphere, above the heaven, meaning there might still be a canopy of water above the stars. Since nobody knows how far it goes, we'll have to just wait till we get to heaven and figure that out. I forget what one guy said. Well, what if it isn't up there when you get to heaven? I said, well, then I'll try to get the message down to you, wherever you are at the time, to tell you about it. So definitely, the Earth today has 6 distinct layers, and everybody does rocket scientists or earth science or atmospheric science will tell you, yes, there are 6 layers to the Earth. It's a good thing, too. The layering to the atmosphere, we have an ozone layer that blocks out certain things, and each of these layers does different things for us. For one thing, just the thickness of it is an insulating blanket that burns up most of the stuff coming in from space. Meteors, etc., they burn up in the atmosphere. Without that, it'd be just like the moon. You know, the full force of the meteor hits, you get nothing to slow it down. They say about 5 meteorites hit the Earth every day that are as big as maybe a softball. Since the Earth is 70% water, of course 70% of them land in the water. Occasionally people get hit by them. It has happened. Buildings get hit by them more frequently. But this canopy that's, I think, alluded to in the Bible, and we'll give you the evidence for and against the canopy theory tonight. If there was a layer of water above the atmosphere, certain electromagnetic frequencies cannot penetrate water. Visible light goes right through, radio waves go right through, but ultraviolet light and X-ray radiation cannot penetrate through water. So the theory goes that this canopy above would do several things for the Earth. It would increase the air pressure, and it would filter out the sunlight and give you none of the harmful effects of the sunlight. So this, to talk about the canopy theory. The Bible also says there was a layer of water under the crust of the earth. It says in Psalm 136, "To him that stretched out the earth above the waters." You never hear that verse preached on, and I don't know how long it took me to catch that that's in there, but I thought, wait a minute. He stretched out the earth above the waters. What is this saying here? Now, some idiots have tried to say, see, the Bible teaches the earth is flat and it's on top of a layer of water. That's not what it says. It doesn't say the earth is flat, does it? The Bible clearly says the earth is round. Psalm 24, "The earth is the Lord's and the fullness thereof, the world and they that dwell therein, for he hath founded it upon the seas and established it upon the floods." There's another verse indicating when God first made the world, it was built on top of a great body of water. So there must have been more water inside the earth. Now, those who object to the canopy theory, the biggest objection they get, and I talk to many people who do not like the canopy theory. I shouldn't say many. There are a few creationists who don't accept the canopy theory. They will say the reason is if you had enough water up over the atmosphere to rain down and cover Mount Everest, the heat generated would cook the world. Now see, when moisture turns to water and condenses, it releases heat. If you're turning water into moisture to boil it, it absorbs heat. So when something changes from a solid to a liquid to a gas, there's a heat exchange. So when going from a vapor to a liquid is called the latent heat of condensation. That might be a good bonus question. Latent heat of condensation, it releases heat. Even though it turns to water and it falls down and it feels cool when it hits you, it's actually released heat to go from the vapor to the liquid state. You have to release heat, you have to take heat away to get something to go from a liquid to a solid state. Freezing. Okay, so here's their objection. Enough water to cover Mount Everest condensing would fry the world. What are the errors in that logic? You're assuming you have to cover Mount Everest. Mount Everest wasn't there, right. And all of these straw men, these scoffers set up, you know, are easy if you look at it. Wait a minute, Mount Everest wasn't there. The Bible says in Psalm 104, during the last part of the flood, the mountains arose. The mountains weren't there. What's the second problem with this? They're assuming all the water came from up above. When the Bible clearly says the earth was founded upon the waters, and that's where most of the water came from. If you read Genesis chapter 7, the same day were all the fountains of the great deep broken up, and the windows of heaven were opened. So here, it says the rain was upon the earth 40 days. But if you keep reading in Genesis chapter 7, you'll see the water kept coming up for 150 days. obviously it's not all coming from above if it's only raining for 40 days. So they always set up a straw man and say, see, all that water to cover Mount Everest would produce so much heat, and they do all these elaborate mathematical calculations, and they're correct on their calculations about how many joules of heat would be, or energy would be released, and that's all correct, but they've got a straw man set up. Yeah, you're right, it would fry the earth. However, all that water didn't come from above. It only rained 40 days. And probably an awful lot of that rain during that 40-day time was being recycled because the climate was all messed up. You'd have had evaporation and a rainy cycle started. Some of it might have come down as rain from when the fountains of the deep broke open, the water shooting up into the atmosphere, and it's raining down. So I don't know how much actually came from the canopy. You'd only have to have, people argue about the thickness all the time, so I hesitate to give a number. But most people say somewhere between 4 and 10 inches of ice would be sufficient to produce the effects of filtering out the radiation. Now, what held it up there is the other objection. I don't know. I don't know anybody who knows. There are a couple of theories about it. Several planets today have vapor canopies that cover them completely. Venus is covered by a cloud cover. Clouds, of course, are 100% water, and they float just fine. If you get water droplets small enough, the surface area is so great compared to the volume, they simply can't even fall. They have to have something to stick to get enough mass together so they can fall. And you have drizzle droplets that form into, I forget the sequence, drizzle droplets to some other kind of droplets, cloud droplets to, maybe it's the other way, cloud droplets to drizzle droplets to rain droplets. They have to slightly get bigger and bigger, and pretty soon they fall. Well, most of the water, I think, came from inside the crust of the Earth. So the fallacy in the argument is they're assuming all the water comes from the canopy. Not true at all. Most of it came from inside the Earth. The Earth today still bears scars. The San Andreas Fault, the Mid-Atlantic Ridge, that crack right there is a crack that was 46,000 miles long. Runs completely around the world, like a seam on a baseball. And it's a real crooked path, which is why it's 46,000 miles long, and the Earth's only 25,000 miles across around. But this rip is probably one of the places where it ripped open. I read an interesting article about somebody who was up in a skyscraper when the 1906 San Francisco earthquake hit. They happened to be looking out the window of their skyscraper, and they saw the ground about 20 miles away. The whole city, the ground and everything, was rippling like a wave. Everything's just lifting up and dropping back down. And they saw this wave come, and all of a sudden their building went and everything fell down, and they survived it. But they described this as seeing the ground itself waving, just like the oceans. Yes, sir?
I was in an earthquake that literally saw the ground go like that.
Yeah, it just goes up and down. I've only seen pictures of it. I've been in 2 minor earthquakes, never been in a big one. But if they say when one of the earthquakes that hit the San Andreas Fault, they checked how fast is the crack moving. If the ground cracks here, how long does it take before the crack moves 100 miles away? And I forget, it was at phenomenal speed. It was like 2 miles a second. That's how fast the crack moves. If you have a tightly stretched cloth, you stretch a cloth real tight, all of a sudden it begins to rip. How long does it take the rip to go all the way down? Well, it depends on all sorts of factors, how tight is the cloth and how much pressure is on it, stuff like that. But the ground in earthquakes will rip at incredibly rapid speeds. So according to Walter Brown, this crack probably circled the Earth in a matter of less than an hour. 46,000 miles. I've seen high-speed movies they take of balloons popping. You get a balloon and you make one hole in one spot. How long does it take for that crack to go all the way around the balloon? Not too long, right? It happens pretty quickly. Or an eggshell breaking. How long does it take for the crack to circle the egg? That's the kind of effect you would have here with the fountains of the deep breaking open. And the Earth today still has what are called continental plates. And when you study earth science, you study the different plates. It's interesting that most of the volcanoes, represented here by the red dots, most of them are on or near a fault line. And so their conclusion is, well, the fault line is causing the volcano. Maybe so. I don't know. There are a couple other theories. You want to read something very fascinating. You need to get Walter Brown's book, In the Beginning, and just read through that, his explanation of what's called the hydroplate theory, about the magma being trapped when the fountains of the deep broke open. And that's still causing volcanoes today. And the likely place for it to come out is where one of the cracks are. San Andreas Fault, I remember standing right on top of that when I was in Lompoc, California. I was driving through the country and I went over the San Andreas Fault. I stopped, and you stand there and you look down both directions and you see this massive crack. And you're thinking, I mean, up these mountains beside it are, you know, really big mountains. You're thinking, man, what if this thing had another earthquake right now? Pretty scary thought. My mom and I stayed in the motel in Alaska where they had the 1964 Alaska earthquake. It happened 30 feet away from this hotel we were in. We were up on the 13th floor, I think. The church put us up in this motel, you know. And you look out the window and they said what happened, the whole section of the city dropped down 30 feet. So they just smoothed it out and planted grass, and now there's a hill there, where before it was just flat ground. We were just looking out the window, looking right down that hill, just 30 feet away from here to that, you know, deck.
How deep is that? Right.
San Andreas Fault varies all over the place. It finally runs out into the Pacific Ocean, just north of San Francisco. Where you were there with them. Did you go see Muir Woods when you were out there? Petaluma, just north of. We were there in just a few weeks ago, right? Yeah. They say California is going to drop off into the ocean. Well, first place, it's just a little piece of California that would be affected, and it's not going to drop off. It's going to slide northward. And that's not so bad, except when it slides, all the rock, you know, moves and everything falls down. The crack is probably, who knows how deep it is, apparently down to where it changes into liquid, maybe 20 miles, 30 miles.
So why don't they, instead of drilling, why don't they do experiments there?
Well, there have been theories tested or attempted. Theoretically, they thought, you know, the reason that earthquakes happen is because the plates are pushing against each other. You do an experiment where you get two blocks of wood or two things that are going to have a lot of friction, two erasers here. If I pull one down like this, they slide past each other. What if I push them together real hard and then pull down? When it finally builds up enough pressure, it jerks. If there wasn't any pressure holding them, it would just slide past each other. But the sliding will cause it to jerk if there's more pressure between it. So what you have here is two massive blocks of earth sliding, and as they build up pressure, and all of a sudden it jerks. It may only move a foot, but the energy released, you know, knocks down buildings for 50 miles. And sometimes they move side to side this way. Other times one drops down. If one drops down, it'll make a big cliff called an escarpment. They have those all over the world where obviously it had an earthquake and a section, you know, dropped down. There are several different types of fault lines. I used to know them when I taught earth science. It doesn't matter. You won't need it for the quiz. Okay.
Excuse me,
Yes, sir.
On that slide you just had there, what are we looking at as far as, are we looking at from an aircraft of many miles away, or are we looking at where, how wide is this crack?
That varies greatly. I would say the total width of this picture at the foreground here where you're looking is probably 2 miles. It's taken from a high altitude plane. The mountain ranges, you know, you're driving across relatively flat terrain, and all of a sudden you see this mountains where it's been built up probably from the abrasion of the rubbing.
What's running down the center of it? Just some kind of...
It's all fills in. As soon as it cracks and slides, you know, the next rainstorm fills it in with dirt, and you can't even tell it's there. It's not like it's an open crack you can look down into the earth. It's closed tight. They build highways over it, and when an earthquake happens, you can see a lot of places where the earth has moved and they had to, you know, rebuild the highway because it moved over 5 feet. Or fences will be off by, you know, 6 or 8 feet.
So you just kind of like got a valley running down through the center of these?
Yeah. You drive up in the mountains, drive down the valley and up the other mountains and out the other side. And if you didn't know what you were looking at, you would think you just drove over some hills. And in some areas, the San Andreas Fault's hardly noticeable. It's not like this all the way along, but an awful lot of it is. Pretty noticeable crack in the ground.